Hello and thank you for watching. My name is Niels Nuyens. In this video, I will share more details on our recent publication of the standard for operational vessel schedules. Our standard for operational vessel schedules consists of multiple documents. The journey to get where we are today started with defining schedule process maps, specifically for long-term and coastal schedules. These process maps are part of the industry blueprint. Defining these process maps have led to also creating definitions that give guidance to the process maps. The definitions are completed with some additional definitions, such as definitions for schedule reliability KPIs, definitions for schedule exceptions, and also definitions for port call time. For the sake of ease, we've also updated the process catalog and added the most important definitions to the glossary of terms. The process maps and schedule definitions have been the starting point for the information model for operational vessel schedules, and specifically the logical data model. The logical data model is an overview of the required entities and attributes, including the relationship between these entities for sharing operational vessel schedule related information. The logical data model at its turn is the starting point for defining the interface standards for operational vessel schedules. I want to highlight three key aspects of the interface standards. The first aspect is that the interface standard includes a subscription model. This means that by implementing the interface standard, it's possible to subscribe to the interface and information will get pushed. Polling the interface for updates is therefore not needed anymore. The second aspect of that is that the interface standard is technology agnostic. That means we don't dictate the technology to be used for adoption of the standard. Having said that, the third aspect is our belief that APIs are the technology of the future. As part of our interface standard, we therefore also define API specifications on Swagger Hub. This should ease the implementation of the interface standard using API technology, as well as secure compliancy. And finally, we have some guiding material on the API specifications on our GitHub page. The documents for operational vessel schedules can be found on our website under Initiatives. I briefly mentioned the logical data model before. I want to spend some additional words on that, given that this should be seen as the reference model and the foundation for our data and interface standards for operational vessel schedules. The model you see here is only a subtract of the logical data model 2.0. That model is the overall model that also includes the entities relevant to track and trace. This subtract, what you see here, is purely showing the relevant entities for operational vessel schedules. And we've split the model into subject areas to provide a more focused overview of the model. I will briefly describe the subject areas as you see them here. The first one is number 3, and it's the transport subject area. Transport is for storing different details of transport-related information. Our model is providing specific industry terminology. We therefore include the vessel entity. Subject area number 4 is a subset of the event subject area. The model design relating to transport is based on the event structure we have published at the beginning of this year. For OVS, events occur with relation to the central entity of transport. Event types can be further related to the estimated, planned, or actual state captured in the event classifier entity, and each event also has specific entities that only relate to those types of events. For transport events, that's for example the delay reason. The next subject area is that for location. The modeling of the location subject area only consists of reference data. To make it possible to track the location of an event, the facility entity is linked to the transport entity. The following 4 subject areas that I will talk about are added to the overall model specifically and only for operational vessel schedules. The first subject area is vessel sharing agreement. Vessel sharing agreement is used as an umbrella term to cover the different agreement types which carriers can agree on. The subject area and its entities will allow for the identification of the partners in a vessel sharing agreement and which trade lane the agreement relates to. Subject area number 7 is for service, the round-trip sequence of ports being served by a vessel on a specific pro forma schedule. Services are the central constituents of each carrier's network, and they are typically operated on a weekly schedule. Transport journey is the 8th subject area and stores each journey of a specific instance of transport. The voyage entity is a subtype of transport journey specific to where the mode of transport is a vessel. And last but not least, subject area number 9 is that for party, and it is reference data that captures all possible codes that uniquely define a carrier. This is just a very brief introduction to the logical data model, designed specifically for operational vessel schedules. As mentioned earlier, this is a reference model. It is not meant to be implemented as such, but serves as reference for carriers and other stakeholders in the industry as the foundation for standardization of data and the interfacing of that data. This brings me to the end of the video, and I hope this was informative and encourage you to share your feedback and questions through our web form. Thanks for watching.